Hello everyone, we are Pacboyz. In this video, I'm gonna briefly introduce our approaches to the Pacman contest. This presentation will mainly divide it into three parts, which are design choice, challenges, and further improvements. I will give more details in the following slides. Firstly, I will introduce the design choice. For this Pacman game, we have two agents in total. We treat one as defensive agent and treat another one as offensive agent. For both techniques, we apply the same defensive agent but different offensive agent, which uses Monte Search and Astar Search. I will introduce both through flowchart and demo. In terms of defensive agent, we detect whether there is an invader by checking whether the enemy is Pacman and comparing the changes of food list for consequent states. We will deal with different situations based on the status of invader using different strategy. As shown in the demo, if there is no invader, our defensive agent will choose a random point on the line of the border to defend. Otherwise, we will further confer whether the enemy has eaten the capsule. If not, we will find a shortest path using Astar Search to kill it. Meanwhile, if the enemy ate the capsule, our defensive agent will chase after the enemies, but keep the distance in a safe range and not too close to the enemies until the scared time is out. As for offensive agents, at the beginning, we will choose a random point on the borderline to launch an attack. Then, when we are in the opponent's side, we use Monte Search to choose actions to attack by implementing a simulation function with rewards and compute the Q value. If the time is almost up or all the masters are eaten, our agent will find the best way home using Astar Search. This demo for MCTs has been double speed. During the situation, we compute the reward in terms of the number of foods can be potentially eaten. And if the distance between our agent and the closest enemy is smaller than the safe distance, we add a penalty to avoid the dangerous actions. But due to the poor performance of the reward function, we might see our agents swings a lot due to the reward value. The second approach we adopted is Astar Search. The only difference to MCT approach is when we want to eat capsules of food. Astar utilizes the external logic to decide the actions instead of using rewards. As shown in the demo, if the distance between our agent and the closest opponents is smaller than a certain safe distance, we consider that we are chased, and vice versa. When there is no enemy chasing after our agent or our agent has eaten a capsule, we will use Astar to find the optimal path to the food. While we are chased, we will compare the distance of safe points, which includes the capsule positions and the border positions, then choose the shortest one. Next, there are some challenging parts in our project. For Astar Search, the performance of Astar Search method is associated with heuristic function, where it's hard to design one. During our coding process, we try several types of heuristic function and finally choosing minimum spanning tree as our heuristic function. Moreover, external logic decide where to use Astar Search. We need to divide our offensive strategy in more detail in order to find the best action. For MCT search, we need to set the number of steps of simulation function and design different rewards strategy based on the safe distance and food eaten. Also, the performance of it is based on the calculating method. It is hard to tune the parameters such as lambda and gamma. For the further improvements, if we want more time to complete this project, we will make our offensive strategy more specific, such as using the game theory and construct heuristic function which can carry more information about food. The performance of Astar Search method will be improved. As for MCT search method, we will formulate a better reward value and penalty based on various situations and continue training our model until we find the best parameters. That covers all I want to say, and thank you for listening.